In this video, we are continuing our final exam review and looking at a consumers/producer surplus example. So the question says, suppose a store's daily demand equation for a new item is Q equals 80 minus 0.2 P squared, where P is the unit price in dollars and Q is the number of units sold. Their supplier is willing to supply Q equals 25 times P minus 4 squared units at price P in dollars. Through a pricing error, one day they price the item at a level at which there is no demand. Find the producer's surplus, and I should add to it, at this price level. So I want to first ask you to pause the video to try this question on your own first. So pause the video for this one, at least 7 minutes to try this question on your own. 4, 3, 2, 1. Pause it for 7 minutes to really try this question. All right, so hopefully you've done that. Hopefully pause there for about 7 minutes to really try this. Let's start to talk about it together. So let's begin with a brief review. So recall consumer surplus. Consumer surplus, even though this question is not talking about consumer surplus, it's asking about producer surplus. Just for review, the integral for this is 0 to Q bar d of Q, that's our demand equation in terms of the variable Q, minus P bar, whatever the price level is, dQ. And similarly, there's a formula for producer surplus. Also an integral from 0 to Q bar. But this function is going to be P bar minus S of Q, where S of Q is our supply in terms of the variable Q. And in these integrals, the Q bar in the consumer surplus integral, it refers to the quantity demanded, because the consumer surplus equation is using the demand function, whereas in the producer surplus equation, this Q bar is also referring to a quantity, but this is the quantity supplied, because producer surplus involves the supply function. All right, so the problem talks about, like, they price the item at a level at which there is no demand. Okay, so we are going to need to figure out, well, what is that price? What is the price at which there is no demand? So let's begin by finding the price such that the demand equals 0. So zooming out so I can see my demand equation, I need my demand to be 0. So I'm going to plug in 0 for Q, where the demand is. 0 equals 80 minus 0.2 P squared. So now let's solve this equation. Rearranging it, we get 0.2 P squared equals 80. And writing this as a fraction, I get 1/5 P squared equals 80. And isolating for P squared equals 80 times 5, which is 400. So then I could square root both sides to get P equals plus or minus, and then square root of 400 is going to be 20. It turns out the negative value isn't possible, so I just get that P is 20. And the reason being is that P, our price, can't be negative. It wouldn't make sense for the price of an item to be negative. Okay, so this is the price level that the question is talking about. So that means that this value is P bar. So next, our question wanted the producer surplus. So to use that formula, we need to find the quantity that is supplied. That is the Q bar term. Okay, so one thing that helps me sometimes is to keep track of, am I looking for the quantity supplied or the quantity demanded is, because I know it's quantity supplied here, I put a little subscript S to indicate, oh, it's quantity supplied. If I wanted quantity demanded, I would put Q bar with a little d at the subscript. All right, so I'm going to use my supply equation, which was Q equals 25 times P minus 4 squared. And I plug in my price value level, which is 20 into this. Q equals 25 times 20 minus 4 squared equals 25 times 16 squared. And if we work this out, this gives us 6,400. And that is our quantity supply. This is Q bar. And again, I'll put a little subscript on it for S because I care about the quantity that's supplied for the producer surplus. All right, so we are ready to now find, let's set up our integral. I know I need 0 to Q bar. For producer surplus, it's P bar, or price level, minus the supply function in terms of variable Q, dQ. So I know P bar, I know the price level is 20. I know Q bar is 6,400. But I need my supply function. So I need to find S of Q. Okay, and my supply function was here. This is my supply function. But when it says S of Q, that means it needs to be in terms of the variable Q. So right now, this is in terms of the variable P. All right, so I need to get it in terms of Q, which means, let's just write the supply equation first. So the supply equation was Q equals 25 times P minus 4 squared, but I need to isolate P to get this in terms of Q, and that'll tell me what S of Q is. All right, so the first step there is I divide by 25 and get Q over 25 equals P minus 4 squared. Then I could square root both sides. So it gets root Q over 25 equals P minus 4. But when I square root both sides, I got to put a plus or minus on one of the sides. So I can isolate P by adding 4. So P equals positive 4. And then plus or minus, square root of the top is just square root of Q. Square root of the 25 on the bottom is 5. So I get P equals these two possibilities. One with this positive root and one with the negative root. It turns out that we can't have the negative square root. So using our knowledge of supply equations, because this is an equation for a supply function, the reason why I can't have the negative square root is since supply must be increasing. And if I had a negative in front of the square root, it would make this function be decreasing. All right, so that is indicating to us that P should just be 4 plus root Q over 5 as a result. All right, so we got our supply in terms of the variable Q, which means this right here is S of Q. And we are ready to plug this in to our producer surplus formula. So we can now compute our producer surplus, or PS. So our formula for that is PS equals integral from 0 to our quantity supplied, which was 6,400, and then our price level, which is 20, minus our supply function in terms of Q, minus S of Q. And S of Q is 4, we just had it, 4 plus root Q over 5. And from here, it's just a little bit of computation to wrap this one up. All right, so we got our producer surplus equals the integral from 0 to 6,400. Distributing the negative sign, we will get 16 minus 1/5, and I'll rewrite square root of Q as Q to the 1/2 because it makes it easier to take the antiderivative of. So the antiderivative of 16 is 16Q, and then I get minus 1/5 times, reverse power rule says add 1 to the power, so I get Q to the 3/2. And then I divide by 3/2, the new power, which is the same thing as multiplying by the reciprocal 2/3. And then I got to plug in 0 and plug in 6400 into this. So if I plug in 6400, we get 16 times 6400 minus 2 over 15 times 6400 to the 3/2 minus what I get when I plug in 0. And I'll get 0 for both terms there. So I'll get 0 minus 0. So simplifying this 3/2 power term, so fractional power means one of these is an exponent, one of these is a root. And the denominator one is the root. So the 2 is the root. And usually it's better to do the root first. Because if you do the root first, you'll work with a smaller number, and then you raise that smaller number to a power. So this whole thing cubed. If I cubed it first, I would get a huge number. And then it's a lot harder to think about what's the square root of that really big number. Okay, so square root of 6400, that's doable actually, even without a calculator. That's just 80, and I get 80 cubed. So I know what to plug in there. So this will give me, let's see, 102,400 for the first term. And then minus 2 over 15 times 80 cubed ends up being 512,000. And I'm going to round this to 2 decimal places. And the units were dollars here. This ends up being $34,133 and 0.33 if I round it to 2 decimal places. And that is my answer.